Hello, welcome to Dapp Mentors. My name is Darlington Gospel. If you're a new viewer on the channel, we welcome you as well. And this is Dapp Mentors, where we help transition Web 2 developers into Web 3. It's been a while, since we released a huge bunch of playlist content, and it's available on the channel. Please do watch it. There are many videos of various kinds. Please go through the channel. You'll definitely find something that is interesting to you. In this particular occasion, we want to introduce a new blockchain network again. Okay, this time around it is called Alephium. All right, now Alephium is a blockchain, not a decentralized storage blockchain, but actual transaction processing blockchain that has smart contract integrated and all of that. This is what we want to work on. So we will also be comparing it with Solidity to see how it match up with the regular status quo of smart contract development that we do have. So this series is just beginning, and we're going to start with releasing 2 videos, and then we can proceed from there. And I'm going to teach you what you need to do to build decentralized application on the Alephium blockchain. So but before we dive into the technical aspect of it, I want to discuss with you what Alephium is, the underlying technology that powers it, and all the consensus model things you need to know, the intricate details you need to know, what distinguishes Alephium network from Ethereum network. You're going to see all that compared. All right, so without further ado, please do not forget to smash that like and subscribe button. It is needed to promote this channel so that others like you and people looking for content such as this can easily find our channel. So please hit that like and subscribe button and the notification bell, and we can jump into the tutorial now. For any blockchain that is coming into this space, there must be something that they offer that makes them unique, different, and special. Okay, that's what Alephium brings into the table. Okay, Alephium has an architecture that is based on sharding. You understand? So the Alephium blockchain is sharded. What does that mean? This means that transaction is broken down into multiple subsets, you understand, that can run parallel, horizontally toward each other. This methodology brings about speed and scalability to a blockchain. Currently, Alephium blockchain processes up to 10,000 transactions per second, which is really cool, and it will put to shame the old Ethereum, which was very terrible at processing transactions faster. Okay, so that is one of the things that makes Alephium special, the sharding provision that the blockchain comes inherently with. Secondly is what is called a stateful sharding. So what it means by Alephium being a state sharding blockchain is that it not only breaks down transactions into subset and process it in smaller shards to improve the speed of the transaction in the blockchain. It not only does that, but it also employs the method of sharding that has to do with each of those small process having their own state. That means they have information about the current transaction. They can retain information about the current transaction, such as the account balance of it, the smart contract, the storage information in the smart contract, and a whole lot of technical stuff underneath it without having to go and look for it in a global stored place or something. So that process, that provision alone has a way of reducing the amount of time that is spent in the transaction, so thereby reducing the transaction cycle, the time that is spent in processing a single transaction. What this blockchain offers, is that speed and that security, and all that. But there is one more step. Okay, so one thing that makes this Alephium blockchain really cooler is that it also provides off-chain transaction processing. Okay, for example, if there is just so much transaction on the blockchain, most of that blockchain can be processed off the chain, which gives another level of speed to the work. I don't know if you understand this, but Ethereum doesn't offer this sort of methods, this sort of advantage, of doing off-chain, data all by themselves, So that is something you should think about. All right, and then also it's a smart contract platform. So a blockchain network that doesn't have smart contracts in it, it's just not such a good blockchain in my opinion, except for transacting money only, or sending and receiving money, which is too basic in my opinion. Okay, so imagine your smart contract running on a blockchain that provides this sharding methodology, and not only sharding, stateful sharding, and also off-chain data processing or transaction processing. Those things, will definitely enhance the speed and the security of the blockchain. Okay, so let's discuss the Alephium consensus model, because one thing you must use to rate or check if a blockchain is good is two criteria. One, you must check on the architecture, which we just discussed, and the architecture must provide speed, scalability, and security. You understand that? Speed, scalability, and security. If a blockchain doesn't provide that, it's not legit. It's not the best platform you should use. Additionally, a blockchain must provide a smart contract platform. This smart contract platform will help developers that want to build application and utilities upon that network. So that's some things that you must look, the first side of the blockchain. The second one is the consensus model or the consensus algorithm. Consensus algorithm is the method which transactions are validated on the blockchain. Okay, so for example, in Bitcoin, it uses proof of work, PWO, proof of work, and in Ethereum, it does use proof of stake. It used to use proof of work as well. So let me tell you a couple of things about the Alephium blockchain consensus model. One, it uses an algorithm called proof of less work. Okay, it's a version of proof of work, but it's actually less of a work. Okay, so this means that for blockchain, for the Bitcoin blockchain, since it uses proof of work, it does consume a lot of energy. Okay, the estimation of Bitcoin energy consumption is even greater than most countries, most developing countries. I mean, just new countries, because of the intense power usage that algorithm does subject your machine into, to validate, to calculate some computations to validate if a transaction is valid or not. But in the Alephium blockchain, it uses proof of less work. So what advantage does it provide? The proof of less work reduces the energy consumption from that of blockchain, that of Bitcoin, to just about, it cuts it down to 90 to 90%. 90 to 90% of what Bitcoin does use, the energy that Bitcoin does use, it reduces it. That is really cool. Okay, so that is a big win for reducing the energy consumption of a blockchain, because many blockchain want to go completely carbon neutral, you understand, and at least this level of just 5%, it's a big win. If you ask me, in my opinion, is a big win. All right, of course these things still need to use a certain level of energy to make sure that they actually validate your transaction and to fight against security security breaches. All right, so that is one thing. If you compare it, I've already compared it, it has less energy consumption, compared to the proof of work algorithm. And one thing you also want to talk about for this consensus model is that it has a very fast block time of 5.7 seconds. Wow, that's really, really small. Okay, so in 5.7 seconds, a new block is created. So why does it have this fast block creation time? It's because of the optimization in the the block in Alephium's architecture of using sharding and low stateful sharding. Okay, and also the optimization of the proof of less work algorithm that it does use. The combination of these produces a faster block creation time. So why is it important that the block creation time of a blockchain is low or is small? It's because that determines how fast the blockchain really is. So the Alephium blockchain has a faster block time. Block time is basically the time that it takes to create a new block on the blockchain. A block is created through mining. Mining is done through validation. Validation is achieved through the participating nodes. Okay, participating nodes. A node is a computer. Okay, participating node means a group of computers on the web running the Alephium blockchain software, and automatically, computational wise validating and making sure that there is no fraudulent transaction that is being added to a block. So that is what the process of all that process taking place, and then a new block is being created and transactions within that time frame are added to that block. That is what Alephium provide, and the creation time for a block is 5.4 seconds. That is very small, very fast, you understand? And that is good for a blockchain. So if a blockchain has a higher block time, it's not cool. But if it has a lower block time, just as this one, that is for every 5.4 second group of transactions are added onto the block, that is a really good one. So that's what the Alephium blockchain does provide in a nutshell. So now let's compare this Alephium blockchain, to Ethereum, the popular one that you do know. So in comparing Alephium to Ethereum, these are the things that you should know. Okay, one, the consensus model is very important that you understand how that differs. Okay, so while Alephium uses proof of less work algorithm, Ethereum uses proof of stake. All right, so proof of stake, what's the difference? Proof of stake basically involves the node validators taking a huge amount of money, of it in the network, so that, but if they make mistake or try to do any fraudulent stuff, and the other nodes, they do not agree on that particular decision that this fraudulent node is doing, it's going to cost them their money, because there is so much of that risk. People that are node validators do not mess around with that. So that is what that consensus model does, and it has its own advantage. But Alephium, consensus model has a great advantage, like I've discussed in the recent slide. So that is one thing you must understand between the comparison between Alephium and the difference or similarities between Alephium and Ethereum. Next is energy consumption. Okay, Alephium has about 90 to 95% energy, cut down rate compared to Bitcoin. Bitcoin basically is like a standard now. It's more like a plumb line for energy usage, because Bitcoin is just crazy in the energy consumption that it does use proof of work. I guess that's why Ethereum has to run away from that algorithm, and so that is cool. For Alephium to cut it down up to 95% is really great, and just relying on about 10 to 5% is amazing percentage right there, if you ask me. Meanwhile, Ethereum has about 95% energy cut down rates compared to to Bitcoin. It has 95% to 99. Okay, 95 to 99. That is really huge. If I have to give that to Ethereum. That has a great energy cut down, basically because of the consensus model. The consensus model really has a way of determining how far or how much energy the blockchain is going to consume, because validating a transaction, if it requires a lot of complex computational stuff, then it's going to really take more energy. But if it doesn't have a lot of complex computational stuff, okay, and rely more on the goodwill of node validators, then it's going to reduce more of power consumption. Another thing that you should take note of, for the difference and similarities between Alephium and Ethereum is that of sharding. Why they both have sharding mechanism? Because Ethereum 2.0 does operate in shard, using sharding algorithm. It uses proof of stake as a consensus model, and then it uses sharding as the architecture. But for Alephium, why it uses sharding? It uses also what is called a state sharding, and also an offline or off-chain transaction processing, which is really cool for situations where transactions are so much on the network, and it has to process some of that transaction off the chain, and that is cool. That is something that Ethereum doesn't have. Okay, meanwhile Ethereum, it relies on layer 2 technologies to process it, to make transaction faster in periods when they have so much so much transactions going on. Okay, so layer 2 method for Ethereum, but for Alephium it's an inbuilt method. Okay, another thing that you should know about Alephium versus Ethereum is the transaction cost, the cost of transaction. This is one area that I really give Ethereum the thumbs down, you understand, because from experience using Ethereum, the transactions are not always cheap, you understand. It's not always cheap, it's often really crazy high, and that is one of the reasons why multiple layer 2 network are built upon Ethereum. In fact, it's not great at all, and the average cost for processing transaction in Alephium ranges from $0.01 to $0.05. So that range, that small amount, is so small. It's so small compared to Ethereum's 0.5 to $2. This is just me, this is not always accurate at the extreme ends. The extreme end can even go way more than what that is, depending on the number of steps that a transaction does have. For example, if you're executing a smart contract, function that has a lot to do with, let's say, if smart contract transfers money, it has a lot of a looping process, a lot of if conditional statement, a lot of steps in that function that you're executing, then it's going to cost way more than what I'm actually listing here. So that is one thing you must understand about Ethereum. It's just that it's not a new thing. Everybody knows this. Okay, not everybody, but a lot of people don't know this, that Ethereum is not often cheap. All right, so that is what you should know about Alephium versus Ethereum. They are both good to me, but the transaction thing is, for Ethereum, is a turn off for me, you understand. But I still use it for teaching purposes. Okay, and because of its popularity, is really great, because it's the first one that came out. But new blockchains are out there, and you should consider using them so that your product might be more usable by the regular user. Okay, because a regular user doesn't want to spend $30 something, $20 something, $50, $10, $15, and $5, and even more on a single transaction. So it's not scalable. It's not really enjoyable to spend that amount of money just to process one transaction. So one thing you also need to understand about Alephium is that you need to understand its tokenomics. So tokenomics basically is about how the tokens of Alephium is distributed, is shared, and it's used. Okay, the Alephium blockchain has about 1 billion ALPs. ALPs is ALPH. Okay, ALPH is the currency symbol of Alephium blockchain. Alephium has 1 billion tokens available for distribution. That is the total supply, basically. 20% of the Alephium token goes to the founder and the team involved with Alephium, project. Meanwhile, 15% goes to the early contributors of building or, raising Alephium blockchain to what it is today. 10% of token of that 1 billion token goes to the advisors, and 5% goes to, for the partners. Okay, this makes up about 50% of Alephium token. Meanwhile, the remaining 50% of Alephium is for the community, and the community, involves those that are mining, which will be the validators, including staking, those that are staking, or an ecosystem development. That is how the Alephium tokenomics works. All right. So, what about its utility? Alephium has a way of it being used. Okay, so just like with other blockchain, for example, Bitcoin basically used for transaction payment. Other than payments, the token can be used for mining as well, which is validation of transaction. But for Alephium, you use the token of Alephium, which is an app, to make payments. Okay, payment valid. Okay, check mark. You can use that to pay Mr. A for Mr. B's, for Mr. A's services, Mr. B for Mr. B's services, just transfer and all that, which is cool because it's a valuable token. Secondly, token is actually used for transaction fee. Okay, because all the payment that is taking place and all that requires validation on the network. So validators get to be paid a certain amount of the fee, which is another way that token is being used, okay, on the network. Without a transaction fee, of course, that nobody will be interested in validating your transaction. So another way that Alephium, token is being used is for smart contract execution. When you execute a smart contract, a series of processes happen under the hood that will also compound to the transaction fee. So execution of smart contract also costs some Alephium token. You understand? To execute that instruction that you're giving, because a smart contract basically is a series of instruction. Okay, so that is what you should know, and it's used for validation, like I've already talked about it. Validators charge are the major people that utilizes the transaction fee. Part of that transaction fee goes to the validators. Okay, and block rewards, whenever there's a need to reward validators, miners, or users of the Alephium ecosystem, that they use also Alephium token to make that possible. All right, and then lastly, governance participation, very important. If just like with Ethereum does have a method for governance, which could be off-chain or on-chain. Alephium does have a governance participation as well that is on-chain, okay, for you to make proposals in there and have that proposals approved by others, even others that will be participating with it, approving it. They must have a Alephium token. They use Alephium token to make that approval possible or rejection possible. Okay, so that is what the Alephium ecosystem entails in terms of its utility. I would like to dive deep again concerning that voting, governance and voting, because it's becoming very increasing that a blockchain, for it to be very good, just need a good voting system that is very clean, transparent, that will determine the future of that blockchain network. In Alephium, voting is done in a decentralized way. So they have decentralized governance, that is done through on-chain voting. So you vote on the blockchain itself. It's not done outside. Anyone that is holding Alephium token, can participate in voting. So you can vote on how you wish that this blockchain network should go, the kind of proposal that you approve and the one that they shouldn't approve. So that is available for all users on the ecosystem. And not only that you can vote, anyone can submit a governance proposal. So you can also submit proposal if you're holding, so you can submit it as well there and it can be approved. So those are who can participate in the voting process and who can submit proposal. The voting mechanism, how does it work? The voting mechanism works in two ways. There are two kinds of proposal for changes on the Alephium blockchain. One is called minor change and another is for major changes. So there are minor changes that people want to make on the network, or things that wants to be brought into the network, and there are major changes. So for minor change, it doesn't require too much of people, but once there is insufficient upvote, it will be approved. But major changes that have to be done on the network, about 2/3 of the governance crew in the Alephium space have to vote yes. So for example, if you look at the way Ethereum shifted from proof of work to proof of stake, that decision is a major decision, and if it should happen in Alephium, it's going to require 2/3 of vote of all the people that voted. 2/3 of them, that is about 60% or thereabout, have to say yes before that decision will be approved and put into effect. Ethereum improved proposals. What if they want to make a governance, if they want to make a decision on the network, how they do the proposal is through a thing called Ethereum improvement proposal. So this proposal will have to be launched by trustworthy or people that are part of that government, you understand, and then when they vote, it will be approved. I don't pretty much think it's on chain. It's not on chain exactly. Meanwhile, for Alephium, it uses a streamlined on-chain voting, while Ethereum doesn't use an on-chain voting means to carry out their governance. Alephium does. So that is a pretty good bonus for transparency and to show to everyone that this is how this network should go. These are the things that are happening in this network and that. So that trust is really important. So that's all that we need to talk about for the breakdown of what Alephium is. I'm sure by now you all know what Alephium is. Please, this step was really necessary so that we all have a great understanding about how the Alephium network works, and hopefully you will not be stuck with the idea that only Ethereum or Solidity and all that works. Added to that, I think I should add this. Please be aware that one major difference again between Alephium and Ethereum is the smart contract programming language. While Ethereum uses Solidity, Alephium uses a blockchain programming language called RAF. RAF programming language is pretty much similar to Solidity, and I'm going to show you in the next video how you can code a smart contract, test it out, and even deploy it on the Alephium chain. You see all that part in the next part of this video. That's being said, now please hit that like and subscribe button, hit the notification bell, and drop a comment if you have any information that you want to say or anything. Just drop comments and all that, you're free. And lastly, I would like to invite you. I'm dropping a link to Hackathon that has just been launched. The link is going to be below here. This hackathon today is 9th, so the hackathon is live today, so you can, it's still early today, it just started. You can actually go and check it out so that you can be a participator. And this video that I'm about to release also will help you to have some basic understanding about how to build smart contract or dApps, on the Alephium blockchain. I hope this has been very helpful, and if it has been very helpful, please hit that like and subscribe button, hit that notification bell, and I will see you in the next part of this video.